Okay, again, we're given a sequence of questions. You're deciding which one you can do, which ones you can't do. I'm going to say it looks like I'm going to say 1 and 3 look like manageable problems. Let me try 1 first. All right, 1 says there's a 5 by 5 by 5 cube, and all faces have been painted red. All right, so number 1. So I know there's a cube, like this over here. Every side's painted red. And then what it says is cut into 125 cubes. So this is cut into 125 little tiny cubes over here. All right, so the total number of cubes now is 125. So let's take a look at this. Some of the cubes will have red faces, that's clear. All right. Right, the cubes are placed in a bag and thoroughly mixed. One is drawn at random and rolled like a die. What is the probability that red face shows, assuming that all cubes are fair die? So there's 125 cubes, right? And each cube has 6 faces. So this is the total number of faces. Let me just make sure. There's 125 cubes. Each cube has 6 faces. All right, now let's talk about the number of cubes that have a red face and how many red faces there are. So let me see. Each side of the red cube originally has a 5 by 5, right? So 25. So if I just paint the top surface, there's 25 red faces there. But now there are 6 sides to a cube. Right? So it's going to be 6 times 25 would be the total number of red faces. I'll just say red side. All right? Well, let's write this down. And the question again is, what is the probability that a red face is showing? So a success would be 25 times 6. That's the total of success. And the total number of outcomes is 125 times 6. The 6s would cancel. 125 goes to 125 5 times. So the chance is 1/5. All right, let's take a look. Yeah, 1/5. All right, let's go for another low-hanging piece of fruit. And I think I just did 1, right? It's easy to make a mistake, though. I want to be honest with you. Don't think that mistakes don't happen when people are doing these things. Sometimes they misread. Sometimes they read, but they really can't understand what they've read. All right, let me take a look at this one up here. You walk 1 mile to school every day. I kind of understand that. I walk to school, and the school is 1 mile away. I'm doing number 2 now. I'm sorry, no, I'm doing number 3. Sorry. So you walk 1 mile to school every day. You leave home at the same time every day. Walk at a steady rate of 3 miles per hour. So my rate is 3 miles per hour. So how much time would it take me to get to school? So it's going to be distance equals rate times time. So the distance is 1, my rate is 3, and that would be t. So t is 1/3 of an hour. All right, kind of understand that. You walk 1 mile to school every day. You leave home at the same time every day. Walk at a steady rate, 3 miles per hour, and arrive at school begins. Today you were distracted by the pleasant weather and walked the first half mile at a speed of only 2 miles per hour. So let's talk about this one. So I walked 1/2 mile at 2 miles per hour. And what would the time over there? That would take me a 1/4 hour to walk the first half mile. All right, to walk a half mile. How much time is left? Well, let's see. You're only given 1/3 of an hour to walk there. And you just wasted a quarter hour. I shouldn't say wasted, you did something, right? So let's see, it would be 1/3 minus 1/4. And this is how much time you got left. That would be 12. And then you get 4 minus 3, which is 1. So there's 1/12 of an hour left. Left to do what? You got to cover a half mile now. All right, so let's see what the question is. At how many miles per hour must you run the last half mile? Well, distance is 1/2. I do not know the rate at which I need to run, but I do know I'm only given 1/12 of an hour to do it in. So what do you get over there? Is that right, 1/12? Let's see, 4 times 3 is 12. Yeah. So what do you got? R would have to be equal to 6. So you have to run at 6 miles per hour. All right, let's take a look at the key. This number 3. Number 3, right? Yep, 6 miles per hour. All right, let me get my eraser out. Kind of look for other problems I can handle. And let me take a look. I am going to try number 4 now. So number 4 says f of x is odd. If f of x is odd, f of x would equal minus f of minus x, all right? They also go on to say that, whoops, sorry about this, that f of x plus 2 is equal to f of x. What does that mean? It's a periodic function. Got a period of 2. Keeps, every 2 units really the same kind of graph. They also go on to say that f of x is equal to x squared, provided the x is between 0 and 1. That does not include 1, by the way. Their question is this, though, and I'll write this one down for you. Their question is, what's f of minus 3/2 plus f of 1? Well, let's do one thing at a time. F of minus 3/2. I want to point out, I really can't use this thing because it says it's got between 0 and 1. So let's take a look around. I'm going to try to use this over here. So f of x plus 2 equals f of x. And I want to know what f of minus 3/2 is. What's that going to be? F of minus 3/2 plus 2. Well, f of minus 3/2 is the same thing as f of minus 3/2 plus 2 is 1/2. Now I can use this function over here. So f of minus 3/2 is just simply going to be 1/2 squared, which is 1/4. So that's done. I got trouble, though, and I'll tell you what the trouble is, f of 1. When I'm kind of looking at that, I can't use this function. But I do know this. I know this part over here. And what would that be? That would be the same thing as minus f of minus 1. Right? I'm just copying that down. And then I could use this. And what's that going to be equal to? Well, let's write that down. So f of minus 1, I'm looking at this over here, right, would be the same thing as minus f of, let's see, minus 1 plus 2 is 1, right? So what does this tell me? I got to be really careful here. It tells me f of minus 1 is equal to f of 1. All right, let's take a look at that. Let's see if I copied everything down right. And I still can't use that other function, though, can I? They got to be equal. So f of x plus 2 equals f of x. I did the f of a half. It's the same thing as f of minus 3/2. I did that. I did f of 1 is the same thing as minus f of minus 1. Oh, wait a second. I don't think I needed to write that down. I have it. I don't know why I wrote that down. So f of 1 is actually f of minus 1. Let me go back, and I have to be careful because I got a little confused there. And I got to go back and read that question here. And what did it say? I got to get f of 1, right? And I used that identity. So f of 1 equals minus f of minus 1. Does that tell me what f of minus 1 is or f of 1 is? Well, let me write that down again then. Maybe that does help me. And what does f... I'm going to use this. I'm sorry, I am going to use this. So this would be... f of minus 1 would be f of minus 1 plus 2, which is f of 1. Well, it does give me that back, doesn't it? Well, let me write that down. Maybe I'm a little confused, but it's f of minus 1 equals f of 1. They're equal. And f of 1 plus f of minus 1 would have to equal 0. Well, if those two things are equal, they'd both have to be 0. Did I make a mistake there? I gotta go back and think. Suppose fx an odd function for which this is, that is, and f of minus 1 plus f of 1. I gotta be careful here, don't I? I gotta be careful. Trying to figure out what f of 1 is. It have to be 0. So 1/4. Let me make sure I'm thinking about that correctly. I'm a little concerned about that now. So f of 1 minus f of minus 1, and then I use the other identity, f of minus 1 plus 2. I see it. Let me see if I do see it. F of 1 minus 1. No, it's okay. F of 1. Where's my doohickey there? F of minus 1 equals f of 1. Yeah, 1/4. Let's take a look at the key. What number was that? Number 4, right? Oh, trickier than I thought. Let's see what they wrote down. I did the same business, right? It's odd because it's periodic. F of 1 equals minus f of minus 1. There, f of 1. Yeah, I ought to think about it. Got 1/4 out of it. All right, that's not bad. We did that. I had a little thinking. I'm a little confused there for some reason. I'm not sure why, but I did get confused. All right, so that's number 4. You may wonder why I get confused. I've solved these problems before, but sometimes it's like years before. And you always can't remember what you've done. So I think so far what we've done so far, I've done 1, I've done 4, I've done 3. I'm going to go to number 2. And it says number 2, the expression a plus b plus c equals 10 is expanded and simplified. How many terms are in your relative expression? They're not asking me to expand it, by the way. But I want to point out, you probably know the binomial theorem. So I'm going to write down a plus b plus c to the 10th power. You may know the multinomial theorem too as well, but let's not worry about that. I'm going to say for the most part, you know that if I took this and I said a plus b equals x, and I said x plus c to the 10th power, well, if you know the binomial theorem, and again, I'm not really expanding it, there'd be 11 terms here. So it would be like x10, the next term, I'm not putting the coefficient down, would be x9 c. The next term would be x8 times c squared. The next term would be x7. I think you get the idea. C cubed, where the sum of the exponents is always going to be 10. And then you actually like yada, 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 all the way down to C10, where there'd be no x in it. How many terms would there be here? There'd be 11. 11 terms. Now here comes the problem, by the way. X is really not x, is a plus b. So it's going to be a plus b to the 10th, a plus b to the 9th times c, and you get the idea. A plus b to the 8th times c squared plus yada, I'm sorry, so I'm not going to put comma, yada, 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 down to c10. All right, I got to start counting terms now. All right, how many terms are we getting? Well, let's write this down. 11 terms here. What's the next guy going to have? The next guy would have 10. And then, again, I'm just going the number of terms now. That's all I'm talking about. And then 9, 8, 7, 6, 5, 4, 3, 2. And the last term is just one term there. I got to add it all together. All right, now I'm going to add that together. I'll point out the way I would do it. Again, I'm not saying you can't use a formula. I'm just saying I wanted to point out some obvious things about the addition of this over here. So if you have 1 plus 2 plus 3 plus 4 plus 5 plus 6, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm sure you saw this story before. That's 12. That's 12. That's 12. That's 12. And that's 12. And then you get a 6 in the end. How many pairs would you get? 1, 2, 3, 4, 5. So that's 5 times 12 plus 6, which is going to give you, let's see, 5 times 12 is 50, 60, 66. There'll be 66 terms. By the way, if you want to, multiply it out. You'll get 66 terms. I don't recommend it, all right? So I want to go the key, and I want to look over it, number 2. Now, number 2 says there's 66 terms. I also talk about, other ways of doing it, knowing that that each term has an A, B, and C in it, where those exponents would sum up to 10. And then I talk about partitions, all right? And by the way, this is a pretty easy, simple ordering problem. What do you got? Let me just count them up. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 factorial. And then what do you got? Well, there's going to be 2 of those bars. That's what's separating these things together, by the way. And you can read that if you want. And then there would be 10 of those stars over there. And it's an ordering of it. And if you do that, you get 66 again. All right? So not bad. All right? That one was, again, you might say, I wanted to multiply that out, and I would try to avoid doing that. And let me just erase this business over here. And let me just see if they did expand it. Yeah, they did. You can count those terms up if you want. All right? But you wonder how I expanded those things, not by hand, by the way. I use a tool to do that. All right? So I wouldn't want to do that by hand. Let me get rid of this. I thought through that one. It wasn't bad. And again, your thinking may be different than mine, but the answers can't be different unless we're wrong. All right? So I got one last problem to do, and I'm saving that last one for a reason. To me, it looks really kind of difficult. All right? So before I do anything, I want to claim to you that this, I can understand people getting stuck on it. One is they might try to do like some computations here. And I don't think it's a good idea to do computation, but I do want to look at it. And the first thing I notice is, A1 is pi over 6. And I notice that, let me write this down for you, AN plus 1 is equal to the arctangent of the secant of AN. All right, before I go anywhere on this one over here, I want to point out that you should know about, what the arctan can return to you. So the an plus 1 has got to be between minus pi over 2 and pi over 2. All right, that's where the arctan is going to return numbers between minus pi over 2 and pi over 2. The next thing I got to look at the secant. You got to look at the secant of that. And someone says, why are you looking at the secant now? Well, I know the A in the problem has to be between, and what I mean by that, the argument of the secant has got to be between minus pi over 2 and pi over 2. And I hope you realize that the secant, oops, sorry about that, that the secant on that interval looks like this over here. That's what it looks like. So what do I know about the secant? It's got to be returning positive numbers. All right, now this is important for me because I'm looking at this now and I'm realizing if the secant on this interval here is returning positive numbers, I know the tangent has got to be, right, the arctangent of it has got to be numbers between 0 and pi over 2. All right. Actually, it could include the 0, but let me make sure I can include the 0. Secant is some number. Could be. No, I can't include the 0. All right, let me just think carefully about that. Secant between there, tangent looks sort of like this over here. I gotta be careful. It might not even be important, by the way. We'll see if it can return a 0. Well, I guess if an became 0, if that's possible, it's never going to return pi over 2, by the way. Get close to it, but never return that. But I guess it could return a 0, right? It seems unlikely that an would ever become... Get close to it, though. I got to think about that again. Might not even be important now. So an becomes 0. I don't know, maybe a little bit of thought. Maybe that's not, maybe I'm just vexing too much on that. So anyway, let's say, look, it says, find the positive inner m. Oh boy, this is going to be tough, right, isn't it? So let me take a look. And I got to think about it. And as I'm thinking about it, let's take a look. So I'm going to just simply, I'm going to concentrate this interval over here. And I'm going to say the tangent of an plus 1 would be equal to the secant of an. And by the way, you may wonder what I'm doing over here. I'm looking at this. And what I do, I just took the tan of both sides, with the understanding that I'm on this interval over here. Now what do I want to do? Oh, boy. I guess I could square both sides, right? And again, this could be a complete dead end. Secant squared an. All right, let's keep thinking. Well, I think I know something about secant, right? The secant squared is the same thing as the 1 plus tangent squared an. All right, let's start writing down things. And I gotta be careful here. I'll write this over here as, I gotta be really careful when I do this because I'm gonna write down the tangent squared AN is equal to -1 plus the tangent squared AN plus 1. And let me start writing this down now. I'm going to try to get a pattern out of it. And I'm not sure if I'm going to get a pattern out of it. So I'm going to write down, let's see. Let's try A1. Well, I think I know what A1 is, right? A1 is just pi over 6. So the tangent squared of pi over 6, well, pi over 6 is 180 degrees over pi. The pi's cancel. And what do you get there? You would get 30 degrees. I just want to remind you, 30 degrees sort of looks like this over here. 1 root 3. So that's going to be 1/3 equals -1 plus the tangent squared of A2. All right, let's write this down. A1 is pi over 6. Well, I already have it written down. I do know the tangent squared now. All right, let me put another one down. So the tangent squared A2 would equal, let's see, we're doing this over here, -1 plus the tangent squared A3. You know, I think I want to rearrange these guys over because I'm not really kind of seeing what I want to see. And that's a problem. When you don't see what you want to see, you keep doing it. So I'm going to write this down a little differently. And let me just take a look at this one over here. I'm going to get my eraser out and tell you what I did over here. This is A1, and this would be let me get my eraser out again. This is A2. I'm not going to put the numbers down yet. I'm going to erase this over here. I don't think I need to do that. Let me erase this too. I'll do the numbers later. The tangent squared A2 would equal, by the way, if you wonder what I'm doing this over here. Let's see. Let's see, 1. Maybe I should write that down again. So, no, I think I can do that. I'm all right. So A2 would be -1 plus tangent squared. I'm just seeing if I can get a pattern. And that would be 3, right? Let me put this one down. Tangent squared A3 would equal -1 plus tangent squared A4. Well, I'm going to write this a little differently, but I could write this all day long. I'm going to write down this way. I'm going to write down the tangent squared A2 is equal 1 plus the tangent squared A1. And the tangent squared A3 is going to be equal to 1 plus the tangent squared A2. And tangent squared A4 will be 1 plus the tangent squared A3, right? I'm seeing something recursive over here. And, by seeing something recursive, I could probably write a general statement down. But I got to be careful. Make sure I wrote the right thing down. And let me just take a look. Did I get the first line correctly? Tangent squared A2, 1 plus tangent squared A1, tangent squared A3, A2, A4, A3. Yeah, I think so. But I got to see if there's a pattern to it, other than the fact that the pattern I've written down. Like I could definitely write down tangent squared let's say, I don't know, AN would equal 1 plus tangent squared AN minus 1. I could write that down, but I don't think that's going to help me out too much. All right, well, maybe it does. I don't know. I want to get a general pattern here. I'm kind of looking at it. And what do I notice it's going to give me? Well, this is going to give me, I'm using what's prior, by the way. It would give me 2 plus tangent, let me make sure I'm saying that right, 2 plus tangent squared A1. And you may wonder what I'm doing over here. I'll find out what I'm doing. I'm taking this, which is this, and just plugging that in. What's next side going to give me? Well, it's going to be 3 plus tangent squared A1. Well, I think I'm seeing it. And I'll point out what I'm seeing over here. This is a 4, and that's a 3. This is a 3, and this is a 2. This is a 2, and this is a 1. So I'm going to say that this over here would just simply be n minus 1 plus. Now here comes the part where I'm going to get a number down for you. And the number for the tangent squared of A1, I think I computed that before though, right? And the tangent squared, let me see, A1 is 30 degrees, right? I'm going to square that number. And the tan of 30 degrees, I think I did that before, right? That's 1/3. Put this over here. So I got a formula. And so the tangent squared, AN, is going to be n minus 2/3. And I got to keep thinking about this. Column number would be 3. That would be 3n minus 2. I got something. They don't want that though, do they? They want this. So I got to write this down now. Gee, I wish I had more room. Sine of A1 is the same thing as tangent A1 over the secant of A1. Right? Let me just make sure it's true. Tangent is sine theta over cosine of theta. And I'm dividing by the secant like cosine of theta. Yeah, that's true. All right? Let's get my eraser out. Conditionally true, by the way. Okay, let's go back. And let me just make a little bit of an erasure over here. I don't need this anymore. And I'm wondering how am I going to do this? And what do I know? I know it's, I'll write this down for you. I know it's tangent A1 over the secant A1 times the tangent of A2 over the secant of A2, yada, 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 all the way down to the, excuse me, the tangent of AM over the secant of AM, and that's 1/100th. All right? All right, so let's take a look. And I can't say I'm close, but I know I'm getting there. Now, of course, in a competitive environment, you might say, what am I going to do now? I guess what I'd have to do is realize the secants are actually related to the tangents. And I got this relationship. I'm going to circle it for you over here. All right, so the secant of A1 is actually just a tangent of A2. And the secant of A2 is just a tangent of A3. All right, let's go to the last one. All right, there's a lot in between it, though. I'm not saying that's obvious what's in between at this point. But I want to go this last. I want to get rid of that last secant. And the secant of AM is going to be the tangent of A sum M. Let's see, what would that be? The secant of M would be M plus 1. All right, I think I know what's happening here. The question is, when the dust settles, what's left? So I hope you realize as I'm going through this that there are cancellations. And they're going like this. There's something here. And they're going like this. So what I'm claiming in the end, when all that dust settles, I'm going to be looking at something. I'm going to be looking at the tangent of A1 over the tangent of AM plus 1. Boy, I'm coming back to that thing again and again, right? Well, let's write this down. Let's write down the tangent of A1. Now, I think I did that before, right? The tangent of A1, that's a tangent of pi over 6. Let me think about that. You know what I'm going to write down instead? I'm going to use this to write down tangent of AM plus 1. And what would that give me using that formula? It would actually give me the root. You know what? Give me a eraser out. Let me write this down a little bit neater. So the tangent of AM plus 1 is actually equal to the root. Remember, we're on an interval between 0 and pi over 2, so I'm not worried about plus or minus at this point. It's going to be the root of 3 times m plus 1, so it's going to be 3m. Again, I'm using this formula over here. 3m plus 3 minus 2, so 3m plus 1 over 3. And I am going to write down the tangent of A1. And at A1, again, I want to remind you, it's written down for you, is that pi over 6, 30 degrees, or pi over 6. And that was equal to, what was that equal to? 1 over root 3, right? Well, let's write this down. It's 1 over root 3 divide by the root of 3m, whoops, my eraser out, 3m plus 1 over 3. I got to simplify that, don't I? And that's going to be equal to, I'm going to start to erase things. This is what your teachers probably do at the board sometimes. I don't need that anymore. That was just me thinking through it. And let me write this down for you. And what's that going to be equal to? I got to be really careful because I'm not even at the end of it. I'm just at the beginning. And this is going to turn out to be, let's see, 1 over root 3 times root 3 over the square root of 3m plus 1, which can be 1 over the root of 3m plus 1. Now someone says, what did you just do there? What we did there was, we just did this part. And what's it equal? It's equal to 1 over 1/100th. Well, I got some work to do, don't I? And can I do that? I think so. So this is going to be 100 equals the root of 3m plus 1. I'm going to square both sides, and that equals 3m plus 1. I am going to, I'm on the home run now. I am going to subtract 1 from both sides. And let's see, that's 10,000, so you can get 9,999 equals 3m. And now I'm going to divide by m, and m's going to turn out to be 3,333. That was our question. Let's see how we did. Again, I know I did some erasures over there and kind of talked through it. And this is typically how I do my chicken scratch. I talk through things. I kind of try to convince myself of certain facts. What number was this? That was number 5, right? So I'm saying m is 3,333. They got that. All right. By the way, my work over here looks a lot neater. I think I wrote down a similar type work over there. I did resolve the 0 issue over here, which really wasn't important in the problem, by the way. And I wrote down the relationships. Yeah, I kind of went through the same thing. But you realize that when people do chicken scratch, it's all over the place. They gotta neaten it up. And this is a neatened up version of it. What's the problem, though, for a lot of students? Even though it might be neatened up, you're still reading this, have no idea where it came from. Hopefully, as I'm talking through that, you're listening through it, you can make sense out of what we're talking about. All right, let me remind you of a couple facts. We're done with this section here. It was tough, though. It was a tough problem. This document is only available to the people participating in the Prison Mathematics Project. All right? I realize other students out there may want access to this, and I want to point out, if you do want access, just kind of email me and I'll let you know when it's going to get published. But right now, there's probably errors in the document that I need to fix. And what I'm hoping that, people are looking at this, and if they see something, they're going to say something to me. And how do you do that? Through email. My address is Bannon, that's B as in boy, the @ symbol, and then nnon.us. Now, there is a slight problem, and I'll tell you what the problem is. Maybe I'm going to be overwhelmed with emails. It's unlikely, though. Who watches this stuff? Very few people watch it. And if they do watch it, they're probably not that entirely interested in what I'm doing anyway. They might give it 2 or 3 seconds and then skip it. They'd never get to the email address. Now, first, this is at the end of it. Some time has elapsed already. If you're still listening, that's great news for me. And if you think you want to tell me something, please do. Please email me. I'd appreciate hearing from you. Thanks for paying attention.